Hello all, my name is Krish Naik and welcome to my YouTube channel. So guys, today in this particular video, we are going to do the custom training of question answer modeling. Okay, and this we are going to do with the help of transformers. I've already uploaded two videos on transformers. One was how we can do the implementation, and the other one we actually try to do a text classification by using fine tuning of pre-trained model. That basically means we used our own custom data set and we trained a text classification model using transformers, HuggingFace transformers. Today we will basically be doing custom training of question answering models, and this also we are going to do with the help of HuggingFace. But understand, for this we are going to use a separate library which is called a Simpletransformer. Okay, now this Simpletransformer, this library is based on transformer library by HuggingFace only. So if you really want to quickly do some kind of custom training and try to evaluate that particular transformer, you can definitely use this. Okay, so this is the entire GitHub page of the Simpletransformer. Amazing work by the entire team who has actually contributed into this, because with very less number of lines of code, you can use the HuggingFace library and you can actually do all this kind of things like sequence classification, token, question answering and all. I'll be covering one by one as we go ahead, but let's see today's example. And in today's example, what I am actually going to do is that let me take one specific data set. I have actually created a side kind of data set for you all, and that particular data set looks like a data set with respect to custom question answering things. So here you can see the data set like prediction, test and train. So in this, first of all, we need to understand how do we create, suppose if I really want to do this custom training of question answer models, you know, how do we first of all create a data set? So in order to create a data set, we already have some input structures that is actually defined when we are actually using this Simpletransformer. So these two links I'll actually give you. I'll also give you the entire data set. Now suppose if you really want to create the data set, your data set should have this kind of format. See, the first format, and it's very clearly written for question answering task. Okay, and this is the entire documentation page of Simpletransformer. For question answering task, the input data can be in the form of JSON file or in the form of Python list of dictionaries in the correct format. So it can either be in the JSON file. Inside the JSON file, it should be in the form of list of dictionaries. Okay, now what should be there? Elements inside that, because in a question answer data set, we should have a question, we should have an answer, right, in our training and test data set. Similarly, so let's see what all things they will be there. So the first thing that you should really have a keyword which is called as context. This context is basically having the entire information. Okay, suppose over here you can see some example. It is basically saying Mistborn is a series of epic fantasy novels written by American author Brandon Sanderson. So this is the entire paragraph I can consider. Okay, and then inside this there will be another field which is called as QAS. Now this QAS field is actually you can just consider that it may be a list of questions and answers, you know. So this QAS is nothing but it is a list of questions and answers. The context is entire paragraph or text. Okay, now inside this QAS, suppose I have only one question. So first of all, I have to provide an ID which is just like a unique identifier for them, and there are some more parameters like is underscore impossible. You know, this is underscore impossible, if I go and see over here, it is a boolean value. It indicates whether the question can be answered correctly from the context or not. If I make it as true, that basically means yes, the question can be answered. If I make it as false, it cannot be answered. Then the question is, who is the author of Mistborn series? So here by this particular paragraph, you know, just by reading this particular paragraph, you have to tell the answer as Brandon Sanderson, right? So this is the entire thing. So this is basically my question, who is the author of Mistborn series, and in the answer you will be having multiple answer options. You can provide in this particular way in list format. So here the first answer you can see it's Brandon Sanderson. Then you have answer underscore start at 71. What is this 71? This, when you count this particular elements, right, one by one, when you count this character, the answer basically starts from the 71st character. So you just count it out, you will be able to know it. So this is one entire information about one context and question. Okay, similarly you may have many number of context and you can basically create a data set like this. Okay, and within one QAS you may have multiple questions also, like this is one question, this is my another question, like this you can also prepare. So what we are going to do is that first of all, we'll try to create this particular data set, and the data set needs to be in the similar format. If you really want to use Simpletransformer, with the help of Simpletransformer, if you probably want to use the HuggingFace library. Okay, this is very much important, guys. You really need to understand. So considering this, what I have done is that I have created this 3 data set. One is test, train data set, and prediction data set. This prediction data set is just like a data set which will actually help us to evaluate. So let's proceed, and first of all, I'm just going to upload the data set over here. So let me quickly reload it. Let me change the runtime also. And okay, this is GPU. I'm just going to save it like this. Now let me do one thing. Let me upload the data set. So I'm just going to select this 3 files. This is in the form of JSON format. And now I'm just going to upload it. It's okay. You can also prepare this particular data set. Not a problem at all. Fine. So we are done with the data set first. And remember, in all this particular data set, you'll be able to see I have used the same format. See, missed burn is a series with all the other options. What are the options inside this? You know, everything is basically mentioned. Here also you can see in the test JSON, all the things are actually been mentioned over here. And in the prediction JSON also, you'll be able to see the entire file properly mentioned. Okay, and I can also expand this. More details will also be trying to come. Okay, so let's go and see this particular data set now. Now before going ahead, first of all, we need to install the Simpletransformers. Remember, we are going to use this, and this in turns uses HuggingFace library, because here you'll not be getting amazing details with respect to custom training or fine tuning, right? I think I just got some information with respect to training, but for the other purpose it is very difficult. But this really has made it very simple. Simpletransformer. So we'll go ahead, and what we are going to do over here, first of all, I'm just going to install this. So pip install Simpletransformers. Until then, I'll just hide this and let this particular step take place. Now here you can see that it has started, and probably it will tell me to reset the runtime also. I think it will tell me. Let's see. The first time I think you have to do this. Okay, please make sure that, guys, this is going to be amazing, because now you'll be able to do any kind of custom training for any kind of class. Let it be question answer, let it be conversational AI, let it be text summarization, let it be text classification, anything that you want, everything will be available with the help of this. Now I'll just restart the runtime. It will tell me to do the restart for the first time, so that you'll be able to use the newly installed version. Now let's go ahead, and probably I will now execute this once again. Now you'll be able to see that it will be saying that okay, it has already been installed, requirement already satisfied. Perfect. Now go with the next step. Now in next step, we have already uploaded 3 files: prediction JSON, test JSON, and train JSON. So we need to read it, right? Now in order to read it, it's very simple. I'm just going to use import JSON with open r train.json as a read file. I'm just going to read it. So let's execute this. And if I go and see my train, you'll be able to see this entire context along with this, what all the questions are there. And probably I need to train my model with this. Okay, so every information is basically there. And remember, the format is in the same format that is basically written over here. That is, it is in the Python list of dictionaries. Okay, in the same format. Nothing, I have not changed. Similarly, I'll be using the same code to read the test data set. So this is my test data. Okay, I will basically evaluate my model based on this. And prediction data set, what I can do, I can just copy and use it, or if I want, I can also read it. Okay, now the first thing, let's see how we can basically implement it. So for this particular purpose, we have to use 2 different libraries, 2 different classes. One is question answering model. This will actually help us to train the model, and this is another is question answering arguments. Now this arguments is also very much important, guys, because there we'll be able to set up many customized arguments. Now whenever we are trying to use this specific libraries, guys, we have a lot of options with respect to models, you know. So there are a lot of models we can actually use. Let me just show you which all models you can actually use. If you go and see this, right, which all supported models it can support. So this will basically be supporting all the HuggingFace transformers model. Okay, like this: Albert, BERT, CamBERT, DistilBERT, Electra, Longformer, MPNet, MobileBERT, Robota. This all models it will be able to support. Okay, so what I will do is that I'll just create a custom code. So over here I'll specify, first of all, I'll import this. Okay, so I'm just going to import these 2 libraries. One is from Simpletransformer.question answering. I'm going to import question answering model, and then I'm going to import the question answering arguments. Okay, so this is imported. Now here I'm specifying that what is the model type. Remember guys, inside this question answer modeling, if you see over here, there are two parameters that goes. If you see this documentation page, one is basically the model type. The model type can be any of this that you have probably seen. Where did it go? Just a second. Okay, I'll just show you. Okay, so first of all, first parameter is model type. Model type can be any of this. Okay, and then second type is model name. Okay, so model name is basically the type of model name that we'll be using. Okay, one is the model type and one is the model name. So what I have done over here based on this, first of all, if I give this particular model type, the model name will be fixed. I've just made it fixed, and if you really want to find out this particular information also, you'll be able to see this. Just a second, I'll show you from where you can get the pre-trained model name. So if you click over here, this is my pre-trained model name. See, it is actually going to the HuggingFace library, like BERT base uncaged, BERT last uncaged. So you can select any one of them. So what I've written, if the model type is BERT, I'm going to use first of all with caged. You can also use uncaged. If I select the model type as Roberta, then I'm going to use this particular model name. If the model type is distal BERT, I'm going to use this. So you can select any of this particular model. Over here, my model type will be BERT. So based on this if condition, it will be selecting the BERT base case model name. Okay, so this is very much simple. So here I have actually selected my model type and model name. My model type will basically be BERT and model name will be BERT base case. So in short, I'm going to use BERT in order to do this training, entire training of the custom training of the question answering modeling. Okay, now after this, whenever we select a specific model from the HuggingFace, we also can set up some parameters. Okay, now what all different kind of parameters you have, or what all different kind of parameters you can play with. Okay, that we are going to show. And over here I'll show you two different techniques for configuring a model. Okay, one is with the help of this particular library that you have installed, that is question answer arguments. Okay, because we are using question answer modeling, right? Question answering modeling, and for this we have to set up the question answer argument. Now if I go and click over here when I'm initializing, okay, these are all the parameters that you can play with. You know, they are all different functionalities. Let me just show you some of the functionalities. If I go down over here, suppose you have maximum answer length, so that will basically show you that how many maximum answer length you can have. Over here you can see one of the feature called as n_best_size. Okay, n_best_size. This basically means that when your question answer model is giving the output, it should at least give 20 outputs, because here the 20 values there. Suppose I asked a question, what will be the answer for that particular specific question? I may get 20 different answers, max to max. Okay, so for that particular value we set this. Okay, so here you can see that you can also set up your, now suppose for question answer argument I'm actually initializing it, and then I'm going to use train batch size. I can use 16, I can use 32, I can use 64. I also have parameters to set, like model arch.evaluate during training is equal to true. I can do this. And then I also have n_best_size, which basically says that you have to give me max to max 3 answers, and you can also set this as number of training underscore epochs, right? So these all arguments later on when you initialize over here, you will be putting it over here. Okay, you can put it over here. I know the name is model args, but I have used train underscore args because I'm not going to use this, because I just want to show you how you have to basically configure the model. The other way is directly use some key value pairs with respect to all the parameters that you're selecting. Now in this particular case, I have written reprocess input data true, overwrite output directory true, catch eval features true, output directory is this. So basically every training will happen, all the weights will get saved inside this directory, which is the best model directory. The best model with the best accuracy will be saved over here. Okay, so something like this: evaluate training time, mask sequence less, number of training epochs. Here you can also set the number of training epochs. So you can play with all the parameters over here. Okay, you can play with all the parameters over here. Every parameters that you want to save, you can save it over here. Now you may be thinking, Krish, what is this WAN-DB project and WAN KWA-RGS? Right, guys, remember, if I really want to see the training visualization, we have to use another library which is called as WAN-DB. Okay, I'll also talk about this particular library. Probably, I think I've installed it somewhere. Let's see. Okay, before this, what I'll do, I'll just install this particular library. So I'll write pip install WAN-DB, right? So this is specifically used for some kind of visualization, which I'm just going to show you. So here you can see that requirement is already satisfied. That is fine. So let's consider this training arguments, and this is the advanced methodology. And now I invalid syntax, training batch size. Okay, what is this error? Let me see. Okay, I stopped using comma over here. Now let me just execute it. Perfect. Now this is got executed. Now all we have to do, use this question answer model, okay, and just give your model name, your model type, and your model name, which we have actually initialized on the top. And this arguments parameter will have this all the training arguments. Now you see over here, guys, none of the folder has been created, right? Now when this entire training will happen, all the folders will get created, like this folder, the output directory folder, the best model directory folder, everything will start getting created. Okay, so what I'm going to do, let's initialize. So I'm going to initialize the model. Let me write the comment over here, initialize the model. Okay, so now the model will download the pre-trained model, because here I've given the model type and model name, and then it will consider all these arguments that I've specified. How do you know this, what all arguments are there? Just go and hover over here, guys. Okay, just go and hover over here. All the arguments you'll be able to see, and with this help of the arguments you can actually see it out. And for this, you check out in the documentation what all the arguments will actually do. But you can also do early training, early stop trailing, everything you can actually do. And probably I'll show you in the upcoming videos also in much more depth. Now this model has got downloaded. Here I don't see any output folders, because if you really want to retrain it again, so you can remove the output folders that will be created. So I'm not going to execute this. I'll keep it like this. Okay, and now what I have to do, I have to just say model.train underscore model with my training data set, and my eval data will be my test data set. So how many number of epochs it will run? It will run for 5 epochs. So let me just quickly execute. This is just more like a sklearn model only, guys. Only prepare the data set and start the training. You know, that simple this simple transformer has actually become. You know, and here I'm actually going to use BERT. See, now epoch 0, you'll also be able to see the loss value and all. This also becomes a squad 2.0. If you don't know about squad 2.0, I'll just make a next video about that. Now see over here, guys, over here you can see something called as project page. Okay, if you execute over here, you'll be able to see the weights and bias. See the graph over here. Everything with respect to the graph, everything will be shown. Evaluation loss, incorrect, how much is the correct, similar, training loss, everything you'll be able to see with the BERT case 2, 3, based on every epochs. You know, this information will be put up. And remember, guys, initially I can see this page directly, but for you know, you'll be getting some authentication. So you have to create your account in 1DB. If you don't have an account, so you'll not be able to see this specific page. Okay, so let me just reload it now. Probably for every epoch, see right now how many epochs has been done. So okay, 5 epochs has been completed, right? So here you'll be able to see all the information, BERT base case, everything. See, training loss, this global step, correct, similar, everything. This kind of charts are available for you all, right? So if you want to try different things, you can definitely try it out, and you can see some graphs with respect to a training loss. And here obviously the training loss is also decreasing, the evaluation loss is also decreasing. Here you can see that some of the information, since there are 5 epochs, so 5 different values will be there. 2 in the first epoch, 2 incorrect, 1 correct, like this, right? Something like this, similar. This is the train loss value. Now you can see it started for 4.8 and now ended in 3.6, right? So this, obviously the training loss is decreasing. I just did it for 5 epochs. If you do it for 10 epochs, probably you'll be able to get some amazing answers. Now let's eval this particular model on test data. This will give us 2 values. One is result and text. Let's see. So what is the result? I'm just going to make this and see what is my results. Oops, it will give us an error because it is a result. So obviously it is saying correct is equal to 0, incorrect 2. That basically means still we need to train, okay? Because none of them have actually got correct in the test data set. But let's see one example with respect to our tray, because obviously, guys, I've just trained it for five epochs. Let's do one thing. Let's train it for 10 epochs. Okay, so in order to 10, I'll just make it 10. Okay, I'll execute this. I'll initialize the model, and before initializing, yes, I'll initialize the model. Okay, and here you'll be able to see this output directory has got created, BERT, This is my best model, everything, right? This is my better model. Here you'll be able to see that .pt file is there, scheduler.pt, all this particular information will be there, right? And if you try to open this, eval results, every details, whatever performance metrics details we are getting, we'll be able to see over here. Now what I'll do, what I have done, I've just made it at 10 epochs. Let me first of all remove this output folder. I'll not require this output folder because I really need to start the training again. So here I'll remove this by using this particular command. Now if I execute this, you'll not be seeing any output folders. Okay, now I will just train it. Now this is going to run for 10 epochs. Okay, so we are going to wait till this entire training will happen. So I'll just close this again. So here you can see project page, run page. So let me just quickly open this. Here you can see the loss will be decreasing with respect to the global step, and every time, every epoch, you'll be able to see that your loss will be decreasing. So it started for 4.9, 4.4, 3.94, so as we go ahead, it will still on decrease, and probably will be able to get some good answers. And here I've just taken 2 to 3 data sets. You may be having a huge data set. Now here you can see that how training is actually happening, right, quickly. So third epoch we are there, fourth epoch, like this. Obviously the data set is small, so if you really want to try big data set, try to create that particular data set by your own. And and for this, yes, you need to know a technique of manually creating that particular data set, and I hope that particular data set is right. And now you can see 3.095 is the epoch. And obviously when you have some bigger data sets, it will take time. So again you can see running loss is now 2.59. Sixth epoch, probably it will get over very soon. Now another 4 epochs are left. Okay, till then, here are your result. So here you can see with respect to the epochs, this is becoming better. In sixth epoch, I'm having this loss. This is also getting less. Training loss is also decreasing. Evaluation loss is also decreasing. Okay, so 2.141. I have this particular thing. Everything is perfect, right? Train and test. Yeah. So 8th epoch, 2.147. So this is just to show you an example, guys. You may be thinking, Krish, why this correct value is not increasing? Understand, guys, I've just taken one data set. If you play with a huge data set, definitely it will work. This is just to give you an idea how to work onto it. Now here you will be able to see incorrect was 1111. Remaining one was actually correct. I had given 2 problems over there, and you can see how the training loss is actually decreasing. Finally we were able to make it as 1.84. Now if I go and execute this, and if I go and see my text, text. So here you'll be able to see that incorrect text, correct text, similar text. Where does the series takes place? Region called the final empire. This was our data set, right? With respect to the test data set, just have a look onto that. And if I go and see the result, probably I don't think so. Since the data set is small, obviously we are not getting that much, but evaluation loss is there. Incorrect is 1, similar is 2. Okay. Now let's test with this example. Okay. I've taken one example where the context is win is a missed burn of great power and skill. The question is, what is win's speciality? Okay, so this is basically the question. Let's execute this, and now we are going to predict on this particular 2 predict data set and see what is the answers. So if I execute it, the answer is born. Okay, so it is basically what is win's speciality? Win's is a missed born of great power and skill. So it has taken this particular born as the answer, but again, if we train it more and more, definitely we'll be able to get some good accuracy. Okay, and probably you need to train for more epochs. Try to train it for 15 epochs, and then you try to see the answer, because as you could see that the loss is still decreasing, right? You can also add one more option called as early training stop, right? So there is also an option in the arguments. You can use that. Otherwise, just play it for 15 epochs, 20 epochs, and let's try to see this particular result. And this wise, here you can see that the output folder is created. The BERT, the best model information is present inside this. Okay, with respect to all the configuration. So just try it by your side. Anyhow, I'll be giving you this entire thing along with the data set, and just let me know whether you like this particular tutorial. Again guys, it takes a lot of difficulty to create a tutorial, make the data set, probably prepare everything for you. So please make sure that you subscribe the channel, press the bell notification icon. I'll see you all in the next video. Have a great day. Thank you and all. Bye bye.